Good morning, everyone. This is Frederick Brock. I'll be leading you through the Android SDK webinar for using PubNub to develop applications. Thank you all for coming, and we're going to go ahead and get started now. I'm hoping that everybody can see my screen, and here we go. So as I said, my name's Fred Brock. I'm support engineer here at PubNub. I've been around for about 8 months or so. I live up in Vancouver, Washington, and passionate about low latency customer support response times. That's a picture of me there at a fish hatchery out in the gorge. I've been doing software for about 18, 19 years now. I've worked on everything from server-sided to mobile apps. So we should have a pretty good webinar here. What we're going to go through today, first we're going to take a look at how you participate in the webinar. I realize all of you are in listen-only mode and can't chime in with questions if we were in the same room. But there is a way you can participate in the webinar, and we'll go through that. Then we're going to take a look real quick at PubNub and just explain what PubNub is. And then we're going to start drilling down into the Java Android API. Everything that I'm going to go through here today is applicable for Java applications as well as Android. Of course, there's some mobile nuances that we'll cover, but most of this will translate easily over into any Java-based application. We'll wrap that up with taking a look at what links are available for resources and look at upcoming events or mention upcoming events. Give you a chance to ask questions through the GoToWebinar interface, and at the end, if you don't mind, please do the quick survey and you'll have a chance to win an OzoBot. So very, very important there. Participating in the webinar, because you're in listen-only mode, please do ask questions. Ask as many as you can. No question is less worthy of any other question. So please do type in your questions in the questions component that's in the GoToWebinar toolbar. That's probably docked on one side of your screen, or if you're on the web, it'll be docked on one side of the browser window. If you type your question text in where it says enter a question for the staff, we have a few people on our side that are answering those questions, and they'll respond directly to you, or if it's something that's consistent, I'll address it to the entire crowd. If we can't answer your question immediately because it's more architectural design related, please do send a support ticket in to support@pubnub.com, and we'll triage that support ticket and respond to you with a more elaborate explanation. Okay. All right. So here we go. What is PubNub? We are a globally distributed and replicated real-time data stream network. So we provide all the infrastructure you need to develop your own real-time applications, and we are much more cost-effective and efficient than trying to set up that kind of infrastructure yourself. We're globally replicated, so if you were to do real-time applications for mobile devices all over the globe on your own, you would need to have data centers scattered across the globe that were replicating messages back and forth, and that would be a very, very costly endeavor for you to undertake on your own. PubNub provides that infrastructure for you. We monitor it, and we ensure that it's up all the time. We also support over 70 different SDKs. So for any environment that can make an HTTP request behind the scenes, you could use PubNub to facilitate your real-time needs. We have over 70 different SDKs. Some of the core ones are the iOS, the Java Android, JavaScript, and Mono C#. But we have integrations with other environments such as PhoneGap and other JavaScript frameworks out there. What is PubNub? PubNub is, as I said, a globally distributed data stream network, and we offer our services, our service in a set of components. Publish and subscribe is one of those components. Stream controller, presence, storage, and playback, mobile push gateway, access manager, and real-time analytics are all different components that make up our service offering. PubSub is what we're going to focus on mostly in this webinar. We also have a stream controller that allows you to aggregate data, presence to allow you to determine who is on a channel or off a channel at any given time. We offer the ability to store and play back messages that have been sent across our infrastructure. And then we have integrations with all the various mobile push gateways out there, such as APNS and GCM. To secure your data as it goes across our network, we also offer Access Manager that allows you to, in a fine-grained manner, determine who has access to a channel or who has access to data when running your application. And then if you want to monitor your application, you have real-time analytics, which will allow you to see messages flying across the globe in real time, and you can get a sense as to where most of your traffic's coming from, what your peak times are, and so on. All right, where are we? First, we're going to look at setting up your development environment. The Java Android SDK, there's nothing super special about it that's PubNub specific that you have to do, but setting up any environment can be a little bit difficult, so I'm going to take you through what I've done to set up the demo app for this webinar and show you how to set that environment up. Then we're going to go into some of these other topics, looking at the Chatterbox demo app, which is available on GitHub, initializing, so on and so forth. Okay. All right, so the very first thing you're going to want to do in order to develop a real-time app with PubNub and Android or Java is download your latest JDK. And I've given a link here. I'm sure most of you on the call already know where to get the JDK or already have it installed, but here it is. If you go out and download the latest JDK, make sure that's installed and functional on your development box before you continue. Once you have that, you're going to want to download the Android Studio, which is available at developer.android.com. And for some of you might know that the Android Studio is similar to JetBrains IntelliJ, which is just a derivative of that and offers some really nice features such as graphical user interface and a drag and drop GUI generator. We use the Android Studio for the webinar. You can use the Eclipse-based version if you want to do that, but for the webinar, I'm going to use the Android Studio. It seems like that's the direction that Android development is heading in. So, follow the instructions. Make sure you have the Android SDK installed and it's properly functional. And the way you would do that is once you have the Android Studio installed, just open and create a brand new Hello World app. It will generate the entire thing for you and make sure you can run that app on the Android simulator. At that point, you'll know that the Android SDK is installed, all the environment variables are lining up, and you're in good shape to proceed. Okay. So creating a new project is very, very simple. Once you have the Android Studio installed, this is the UI as what the UI looks like. You have the Android Studio, just do a file new project, and it gives you a variety of various options for creating new elements in your project off the file new. Okay, so once you do a new project, it will just ask you where you want to store that project, and it will generate the project for you. At that point, you have a working Android application. Now you need to start integrating the PubNub SDK. And I'm just going to hop out of the slides here and take you into IntelliJ, and I'll show you what I have configured for my PubNub application. So, all right. So assuming you've got your application all created, you'll be sitting with a view similar to this. And you have your project navigator and then your code window and then your console window at the bottom here. Not that big of a deal. The file that you're going to want to modify is your Gradle project. You'll probably have two different Gradle projects. One will be for the workspace and the other one will be for the app. You want to add dependencies to the one for the app. And that's a second Gradle project. It'll say module app below it. And within that module Gradle file, which is the build file, for those of you that are familiar with Maven, Gradle has come along. It's a Groovy based build tool that allows you to do transitive dependency resolution and so on. You'll want to add the PubNub dependencies to that file. So down here at the bottom, I have a dependencies element, and within that dependencies element, you'll notice that I have the Android, PubNub Android debug jar specified, and in this particular case, I'm using 3.7.2, although 3.7.4 is the latest and greatest version. Feel free to modify that, okay? But once you have that dependency listed in your dependencies element, that's really all you need to do to install the PubNub Android SDK. We do publish out to the Maven repository. Gradle will then turn around and go out and look for that dependency there and pull down the jar that is required to develop PubNub applications. You don't need to download anything off the website. There's no class path variables or variables that need to be configured. You simply need to add this dependency to your project, and you should be in good shape. You'll notice I have debug here. Debug is one way to do it. Once you get a production ready build, you'll want to switch over to the production jar. And all that does is remove the diagnostic information that PubNub produces when you run your application. During development though, definitely keep the debug jar in. It'll give you really good insight into what the SDK is doing and whether or not you're getting an error or an exception being thrown, and that could be very, very helpful for us on the support side as well as you. So, all right, go back in here. So again, just make sure you have your debug jar in there and use the debug for development, remove the dash debug for production, and you should be in good shape, okay? All right. There is a demo application for this webinar that you can download and use. I'll be publishing updates to it as we progress with development of the webinar. But for right now, it's a very, very simple single channel web application or chat application that you can use as a bootstrap for your own development or just look at for examples. Feel free to make changes to it or submit comments about it or submit support tickets about the code. We're happy to help you out. Some of the features that it has are global chat. It also does presence, so we listen to who's actually logged into the chat application. It does have some hooks in it for doing private chat and push, and I'll go through that today. And again, we'll be publishing updates. Just to show you where that's currently at, if we hop out to GitHub, I don't know if you can actually see my my screen, but there's a GitHub repository. It's called PubNub-Android-Chat, and I'll put that in the chat window for you. There's two branches. There's a master and a dev, and right now the code is still on a dev branch, but you can come in and clone that, swap over to the dev branch, and you should have the application and all the code associated with the application in a buildable single channel chat app. It doesn't work so hot on the simulator. It works much better on the device. Android simulators are a little bit different, a little bit finicky with some of the UI elements that I'm using. So please do run that on a physical device. Okay. All right, hop back over. All right, so once you have all that, and here's a small architecture diagram for the Chatterbox app and how I use it. Once you have everything set up, you can pull down the code and start experimenting with it yourself. The architecture is set up such that I've encapsulated all the PubNub interaction behind an actual service, so what we call a sticky service on the Android side. The service actually does all the interactions with PubNub. And then the UI plugs into the service. The service notifies the UI of messages that have arrived. And then below the UI, I've also integrated Google Plus, so you can use that to pull in user profile information. But architecturally, you want to stick to a pattern similar to this. Instead of having PubNub throughout the entire application, you want to encapsulate it in one spot. As you'll see with the API is very, very simple. There are about 5 or 6 different methods that you need to use off of the PubNub facade object. And if you can encapsulate it in one spot, it makes it easier to troubleshoot, makes it easier to make adjustments to the application in the long term. So when I was writing the sample application, I created the service. The service actually interacts with PubNub, and then I have some listener interfaces that notify the UI of chat messages as they occur. Okay. All right. All right, so how do we do that? Now we're going to look at initializing the Java Android SDK. It's very simple to do. And then we're going to start moving on to subscribing to a channel. Okay. All right. Initializing. Initializing the SDK is fairly simple. You have about 2 imports that you need to add to your code, actually 3. One is a callback. The SDK is asynchronous, and as a result of it being an asynchronous environment, when you make a call to PubNub, what you're doing is saying, will the infrastructure do what I'm asking? When the infrastructure is done doing that, it makes a call back and notifies your application. So all of the calls we make from the application off to PubNub accept an attribute called callback, and that callback is used to notify your application when what you've asked is either done or couldn't be done, and we'll take a look at that. The PubNub facade object, this is the single object that you'll have to import that allows you to interact with the PubNub infrastructure, and you'll want to import that into your application. And then all of our calls have that potential to throw an exception or throw an error, so you want to catch PubNub error as the exception. Okay. Again, I want to stress it is an asynchronous environment. So when you do Android applications, you can write code that doesn't run on the UI thread, particularly when you're dealing with list views or dynamic UIs. You want to make sure that you ensure that any UI code actually runs on the UI thread. PubNub runs on a background thread by default, so when your callback is invoked, it's not running on the UI thread. You have to run on the UI thread, and I'll show some examples of that during the webinar here. Okay. All right. So again, the SDK invokes REST HTTP requests behind the scenes. They're asynchronous. Callbacks are passed to all the calls as the mechanism for the SDK to inform your application that certain operations have been completed, and you need to implement the callbacks. Okay. What does a callback look like? It always looks the same, no matter what you're dealing with. If you're dealing with presence, a heartbeat sensor, or just normal pub sub, you'll implement a callback, and here's an implementation of a callback. Callback is the default class that implements all the various methods within the callback interface. And one of the methods on that interface is called success callback. Accepts a channel and a message. We'll get to that in a minute. And then you perform your logic. You wire that in usually by passing the callback as the second parameter in the call. So, all right. Jumping over to the code here. So implementing the callback. So as I said, we have a Chatterbox service that extends service. This is an Android concept. And the service runs behind the scenes. It runs in the same process space as the application. It can be configured to run in a separate process space. The reason why I chose to go with a service on the Android side versus just wiring PubNub into the UI or closer into the application is I might want to develop widgets or do other things on the mobile device using the same PubNub connection, and a service allows me to do that. Services can be bound to by any activity as long as they understand the interface. And so that's why I went with a service. This service has some default constants associated with it, which are my pub and my sub key. I'm actually using a sandbox-based key. And the reason why I did that is if I'm wanting to do GCM, I need to have an independent key. But you'll want to change these to be your pub and sub key. I'm keeping some state around. I keep a list of Chatterbox callbacks, which are not PubNub callbacks. They're slightly different, and I'll get to that. And I also keep a global presence cache. And when we get to presence, I'll talk a little more about that. Here's my heartbeat callback. It's being, let's see if I can expand that a little bit. Just implement the callback, override the callback, and implement the success callback method. And here's where we do our initialization. So again, we have our imports here at the top. You can see the PubNub-based imports right here. Okay, and I'm catching generic exception. That's why I don't have PubNub error, but you can import that. So I have my imports there. And then I have a get PubNub method that's called, and what I do is a lazy instantiation of the PubNub instance. So if it's not instantiated when I call get PubNub, I create it then. But I essentially create a new instance of PubNub. I pass in my publish and subscribe key, and then the true parameter is for using SSL. If you're going to use secure communication, you would want to pass true. If not, you would want to use false. I would definitely recommend that you use SSL. Okay. Ensure that you get the argument parameters correct because they're both strings. A lot of times people will transpose this and pass the subscribe key first and then the publish key second, and that will cause you some errors with your subscribe. But it's publish, subscribe, and then for SSL. And there are various overrides to this that accept different parameters. But at a basic level, you'll want to use these three parameters. Okay. Once I do that, I set up my heartbeat. The heartbeat is a small ping that sends a message back to the PubNub infrastructure and says that this subscriber is still here. Heartbeats on mobile devices, you probably want to pump them up a little higher than what the default. Here I have 360 seconds. And if PubNub doesn't hear from this subscriber within that allotted amount of time, then it will think that the subscriber has timed out. Okay, so I'm setting a heartbeat here. For mobile devices, you want to have this heartbeat as far apart as possible. With mobile devices, as people are walking down the street, they could be swapping IP addresses, they could be jumping on and off Wi-Fi access points at coffee shops, and what happens when those events occur is you're temporarily disconnected and then reconnected, and that's at the mobile device level. Well, when you're disconnected at the mobile device level, PubNub obviously can't function. So if you set these heartbeats so that the interval is long enough in between heartbeats, you have enough time to weather the temporary connection interruptions caused by folks being on the go. So you definitely want to pump that up. Or if you know your app's going to be used in an area that has 3G or some kind of a shoddy mobile access, you definitely want to have this heartbeat set up such that you're giving the application enough time to ping PubNub and let them know that they're still there. Otherwise, you'll get a lot of false subscription timeouts. All right. Set resume on reconnect. This is another initialization parameter. And what this means is during those times when you have those temporary connection interruptions, messages may be sent. This setting will ensure that when you have that interruption, when PubNub reconnects, it will ask for the messages that have been sent since its last subscribe call. Okay, so this will ensure that you don't miss messages as a result of a temporary connectivity issue. Subscription timeout, this is how long it will wait for messages to arrive on a channel before it returns, and I'm setting that up to 20,000, so that's going to be in milliseconds. And then a UUID, and I didn't set it here, but you definitely want to set a UUID. UUID is how we recognize you on the PubNub side, particularly as it applies to presence. So when you instantiate an instance of PubNub and you set the UUID, our Presence API will use that UUID to notify others that you've joined a particular channel. Okay, so you definitely want to set a UUID. And as I'm passing here, I didn't want to do this because I don't like using emails for that, but a UUID could be any unique identifier for that particular user or that device, whatever your use case is. And usually most of our customers use a user ID of some sort or a profile ID for the UUID so that they can correlate the real-time messages with their other data store, okay? And then I'm just setting initialized equals true, which is just a parameter I use to determine whether or not I'm up and running. But that's how you initialize PubNub. Very, very straightforward. Instantiate the PubNub object, set your parameters that will dictate how the SDK behaves under certain conditions, and then cache an instance of that and return it to your application. You only want to do this one time during the life cycle of your app. You don't want to instantiate PubNub every time you need to subscribe or every time you want to publish a message. Limit it down to one instance if at all possible. It is possible to have multiple, but not very practical. Okay. All right. All right, so we've initialized PubNub and taken a look at the various parameters required to initialize the SDK. Again, initialize or instantiate an instance of PubNub, set up your various parameters, and you're in good shape. All right. Minimum data points, subscribe key, publish key, you use SSL. You'll want to at least pass these three values to the constructor of PubNub. There are overrides that you can use to more fine-grained, give you more fine-grained control over how the SDK behaves. And a list of those overrides are available in our documentation, which I'll pop out to next time we go out to the code. Okay. Again, configure the instance of the behavior of the SDK by setting the heartbeat, the subscription timeout, and resume on reconnect. Okay. Subscribing to a channel. All right, so we're going to subscribe to global chat. And before I do that, I want to just describe a channel. Channels identify the destination for a publish and subscribe message. They're dynamic. Meaning you don't have to do anything server side, you don't have to register a channel. They exist when you subscribe to a channel or when you publish to a channel. On the infrastructure side, that's when a channel is going to exist. Again, nothing to be done, just give it a name and either publish or subscribe to that channel and that channel will exist. You'll hear me say channel. Channel is the conduit or the point for or the destination for a message or the point of consumption for a message. Okay. In our app, we have two channels. We have a personal channel. We have a public channel called AWG-global. That's the channel. Okay. Subscribing to a channel is fairly straightforward process. It can be involved depending on what your use case is. From the PubNub side, there's just one call that you need to make, and that's to subscribe. You give it a channel name, and then implement a callback. And I'll hop out to the code. Let's get in there. So for us, the subscribe goes into a room. Chatterbox is a collection of rooms, and so I have a service, and on that service I have a method called add room. It accepts the name of a room, so that would be the channel name that we want to use, and then accepts a Chatterbox callback. And let me just pop over to that real quick so you can see it. This is a Chatterbox callback that I created, and it's the way that the UI talks to the service. And so on this callback, I just have a few methods. There's an on message and on presence, and then a few others that I'm currently not using, but you can use on heartbeat, on error, when a private chat happens, disconnect, or on connect. Those methods would be invoked. And then I have a few domain objects that wrap the message content going across the wire: Chatterbox message, Chatterbox presence message, or a private chat request. Okay. Going back over here. So my method accepts the Chatterbox callback. I check to see if I'm initialized. If you remember when I initialized the SDK, I set an attribute. I'm checking that here, making sure that I'm initialized. Because this service is going to be running, and it may be running when an app isn't running. So I want to make sure I'm initialized, and I don't want to tie that to a screen being present. And then I grab a list of the channels that I'm already subscribed to. I could be subscribed to a channel already. And if I find that, then I don't call subscribe. However, if I don't find a channel, then I call subscribe. And here I've got my service. I grab a reference to PubNub, so it will initialize it if it hasn't already been initialized. And then I call the subscribe method. I pass in the name of the room that I want to subscribe to, and in our case, it's always going to be AWG-global. And then I implement a new instance of callback. So that's the PubNub callback that we're implementing. And on that callback implementation, I implement a success callback. This is what's going to be invoked when a message is sent to a channel from some other device or some other system. Okay, this is the method that will be invoked, success callback. It's passed in 3 objects. An instance of a string that is the channel that has been has a message that has been published to it in which you're receiving the message. The message itself, which is usually a JSON object, or it could be a string, could be either one. It's either going to be a JSON object or a string, and then a time token. The time token is when the server processed that message. And within the implementation of that method, I'm just logging out that I've received a message. I'm checking to see what type of message I have, and I'm checking to make sure it's a JSON object. For my app, I'm assuming that any data being sent over this channel is always going to be in a JSON format. You could send text as well. Usually JSON is the way to go. If it is a JSON object, then I do a downcast here from object to a JSON object called JMessage. And then I start to get attributes from that JSON object. And in this particular case, I'm grabbing an attribute called type, and I'm storing it here in message type. And I'm checking to see if it's a chat message. If it's a chat message, I create an instance of a chat message domain object. I loop through my listeners that are listening for that particular room, and I just call the on message. So right here, this is application specific. This is PubNub specific right here. Okay. So anything, if you want to subscribe to a channel within PubNub, you're going to use the subscribe call. Everything else in here is the way that I've chosen to implement that, which is I have a JSON object that's sent across the wire. I use a type parameter within that JSON object to determine what kind of message I'm receiving. And if it's a chat message, I create that type of domain object. To expand on this, you could also have image or an attachment message or whatever you want, and you can implement that the way you see fit. But in this particular case, it's a simple chat message. Okay, and then I notify listeners on that room that that chat message has been received. Just so you can take a look at what the schema looks like. This is the Chatterbox message. These are the attributes that are in that message, and these are kind of randomly selected. I've selected them just based on using other chat apps. I have a device tag that tells me what kind of device sent the message. If you had a website and a mobile side, you might want to know that. What type of message is it? Who sent it? When did they send it? Was there an emoticon associated with it? What was the content of the message? And then I give it a message ID and the sender's UUID. And that allows me to identify who sent the message, where they sent it from, and the content of the message, which should be enough for you to develop a UI that allows your user to know who sent a message back and forth. Okay, and I just use this object. I create it from a JSON object here, create a new instance, and I just grab all the attributes out and store them in instance variables, and then return that. Okay. All right. And that's how you do a subscribe. There's not a whole lot more to subscribe. It's really just this call and then implementing your callback. Okay. All right. All right, so we just took a look at that. There's our subscribe. We have our implementation of our success callback. There's also an error callback, and that will occur when the subscription fails. Going back to the initialization, if you recall, I spoke about the subscription timeout. If the timeout elapses, then your error callback will occur, and you'll get an error. Or if your device isn't connected to a network, you could get an error, and the error callback would occur. Okay. Always implement your error callbacks, even if you're just going to log a message out, such as I have here. But you're going to want to notify the user that something happened, or at least have a log message so that you can determine or better diagnose what the problem is, or if you're sending in a support ticket, having these error callbacks implemented just go a long way in boiling down what the problem is and how to move forward. So publish, moving on to publish here. Publishing a message would be sending the message from the application. Very, very simple to do. You're going to want to call the publish method within PubNub. And that's very straightforward. Here's my implementation of a publish method. I have a JSON object, instantiate a new instance of a JSON object. I create a Chatterbox message. Using message JSON put and just putting the attributes in a JSON object. Okay, and then I use PubNub publish, pass in the name of the channel that you want to publish a message to, the JSON that you want to publish, and then implement your callback. And then the true here is for storing the message in history. Okay. In this particular case, I'm just logging out that the message has been published. You may want to have a UI indicator that allows the user to know that a message has been published, and as well as an error callback. Okay, so just doing a try and a catch there. Hop right over to the code. All right. Find my publisher. There we go. So here's our implementation of publish. Very, very straightforward. We have a publish, and that's, again, it's on the server side. We instantiate a JSON object. We populate the JSON object with our content. We grab a reference to PubNub, and we do a publish. And we have a success callback here. I'll expand on that a little bit. That just logs out that the message has been successfully published. As I said earlier, you probably also want to do an error callback as well. But I'll leave that up to you there. Always implement your error callback. If there's an issue with the publish, your error callback will be triggered. You'll know that there's a problem, and you can diagnose it from there. Okay, very straightforward implementation. As far as how that ties into the UI, if I go down to the UI, all the UI screens for the demo app are roughly the same. You have a fragment. I use Android fragments in order to implement the UI. The fragments implement an on-fragment interaction listener. This was a freebie given to me by the Android Studio. It generated that part of it. All the fragments are user context aware, so they're usually instantiated using a user profile, however you've logged into the application. And then there's an instance of a client. The client is how you interact with the service, and you register listeners with that client so that the service knows who to call back. The way that I do that is using a service connection. So let me go down to where that actually occurs. For fragments, the Android lifecycle will call onAttach. That means that your fragment is being attached to an activity, meaning that the user is going to look at your fragment. And at that point, I always call superattach. That allows any initialization that needs to occur for this particular fragment to happen. Then I use an intent. This is an Android concept, very similar to a process, but it's the way you interact with other components within the mobile device. I pass in the activity. I pass in the service that I'm interested in. And then I do a bind. And this is how I bind back to the background service. I pass in the intent, an instance of a service connection, and then the auto create, meaning if the service isn't running, go ahead and start it. And whenever that happens, this bind service call will look at this service connection, and when it's instantiated the service and bound this activity or this fragment to that service, it will make a call back to my service connection. Here's the service connection. At that point, the service onConnected or onServiceConnected method is invoked. It passes in a component name and a binder. The binder is the client. So I do a downcast here on that service to Chatterbox client, and I store a reference in an instance variable on that fragment. And at that point, anywhere else within the fragment, I can interact with the service and use any of the public methods that are exposed on this particular client. Whenever I disconnect, I'm simply logging out a message right now, but you could shut anything down or close any resources that you may have open. Okay. So what happens at that point? That happens prior to the onCreate. Android will then call onCreate. You can do any additional initialization you need there, and then eventually it will get down to onCreate view. And in this particular case, I just grab back the fragment. I look for the send message button, and then I tie a click listener to that send message button. And so whenever you click, it will grab that text and send out a message. And here's my service client. Okay. Obviously, you want to make this a little bit more robust, check for connectivity. I'm doing that. That's a very basic check. You're going to want to also check that the user can send a message and who they're sending it to is available and so on and so forth. But at a very basic level, make sure you're connected and then send out your message. And here I'm just sending it out to awg-global. Okay. All right. So that's how you do a publish, and it's very, very straightforward. Again, the content is completely application specific, and call the publish method, implement your callback, make sure you implement your error. All right. When you call publish, the returned array will give you an idea that the message has been successfully sent. In this particular case, the callback will be sent in a success flag, a status message, and a time token. You can use that time token to go back to history and retrieve that message at a later time. Or you can use the time token to format and display the date to the user. So here's an example of a successful publish or successful callback payload, and an example of a failed. If in the event that the message fails to publish, you're going to get the callback will receive that. It will have a 0. It will tell you why the message failed to publish, and also give you a time token. Okay. In this particular case, the message is too large because it's greater than 32 kilobytes. PubNub has a constraint on the size of the messages that need to be or that can be published across the infrastructure, and that constraint is 32 kilobytes. So. All right, so we've set up our development environment. We've taken a look at the Chatterbox demo app. Again, that's out up there on GitHub. We've initialized the Java Android SDK. We've subscribed to a channel so that we can listen to messages coming in from the channel. Again, it's just a matter of calling subscribe and passing in a callback. Now we need to determine who's actually on a channel and when state changes occur. And that's what we'll be looking at next. All right. So presence and state, PubNub offers presence and state API. It's actually an add-on to the core PubSub capabilities, and it allows you to listen for join, leave, and timeout events on any channel. So in a chat application where you would typically have a roster of users that are currently logged into the chat app, you're going to need some way to generate that roster and keep track of who's active on a given channel. Presence allows you to do that. Presence will notify you when somebody joins a channel. They'll notify you when somebody unsubscribes from a channel, and they'll notify you when somebody walks away from the app and allows the presence timeout to occur, which would trigger a timeout. Okay, when you create a channel, it doesn't matter what channel it is, you're actually creating two channels on the PubNub side. There's one channel with the name of the channel, which in our case is AWG Global, and the second channel is AWG-Global-PN-Pres. That suffix of PN-Pres is the presence channel. So you can actually subscribe to just the presence channel and just get presence events, or you can subscribe to the channel and then tell the SDK to also listen for presence events on that particular channel. Okay. A few different events will occur when you subscribe to a channel, and I have those laid out here. A join event. A join event is when a subscriber joins a channel, and it's as a result of calling the subscribe method. Okay, what will happen is we'll create a subscription on the SDK side, which essentially means it's going to monitor that channel for any traffic, and then a join event will be triggered server side saying that a particular UUID has joined the channel. This is why it's so important for you to set a UUID when you initialize PubNub. The UUID is what you're going to use to uniquely identify a given instance of the application across the PubNub infrastructure. Okay. Leave. Leave is when a user unsubscribes from a channel, and I have to stress that. You won't get a leave event if you don't call unsubscribe. So when a user exits out of your app or your on pause occurs within Android, you're going to want to ensure that you unsubscribe from a channel. What will happen when you unsubscribe is the presence API will trigger a leave event, and then everybody else on the channel will know that you've left that channel. If you don't unsubscribe, what will happen is you'll remain present on the channel until your heartbeat times out, which could be up to 5 minutes later, and you'll get a timeout event. Both of these will have the same data, the leave and the timeout, but the timeout will not occur until sometime after the user has actually left the application. Okay. And then finally, there's a state change event. For every channel, for every UUID, you can maintain a unique state on a particular channel. And an example of state would be a do not disturb flag. If I'm in the global room and I don't want anybody to disturb me by sending me chat requests, I could put together a JSON packet that represents a do not disturb flag, and I can send that out as part of my state when I join a channel. And then others would know that I do not want to be disturbed. That's just an example, but you could also use a state change to propagate data on geolocation or on mood, emoticon, whatever the case may be. Whatever kind of state data you want to keep for a given UUID, you can put that together in a JSON representation and send that along when you subscribe. Okay, and that's state change. All right. What does a payload look like? Here we have an example of a join payload for the join event. All the payloads look very, very similar to this, with the exception of the action attribute being join versus leave, timeout, or state change. And here is an example of that payload. So we have an action, tells you what just happened. Was it a join? When did it happen? That will be a time token. Who triggered that action? Who joined? Who left? Who changed your state? For join and leave events, or join and leave events, you'll have an occupancy count that will tell you how many people are actually on the channel. And then you'll have state, and this is application-specific JSON payload that can represent your state. And in this particular case, we're giving the state of the name of Craig and a city of San Francisco. So if Craig moves out of San Francisco, he'd change his city, he could change his state. And state is per channel, per UUID, meaning if I have one person subscribed to multiple channels, they're going to have different state on each channel. Okay. Subscribing to presence is very, very simple. Again, it's the same pattern as all the other calls. We have our instance of PubNub. We call presence. We pass in a room name or a channel name, and then a callback. And in our case here for the sample app or sample code, I actually have an implementation of a presence callback called presence callback that accepts a few parameters, and I'll take you through that in just a second. All right. All right, just a small segue. We do have documentation on the Java SDK. That is up on our website. If you go to the website and go under developers, there are documentation links here. And then once you get to that, there is a Android link, and that will get you to the Android SDK documentation. And it does have copy, paste samples and descriptions, as well as an API reference that you can look at that will give you the ins and outs of the various calls available within the Android SDK. All right, did want to mention that. And jumping back over to the code, we were looking at presence. So let's go back over here real fast. So when do we listen to presence, or when do we tell the SDK to listen to presence? So we've subscribed to a channel. When we subscribe to a channel, that's the time when we want to also tell the SDK to listen for presence on that channel. If you're familiar with the JavaScript SDK, you don't have to do this. It's all one call. You call subscribe and pass in a presence, a reference to a presence function, and it will invoke that for you. For the Android SDK, it's slightly different. You have to call them separately. You call subscribe first, and then after I've done my subscribe, then I also want to listen for presence. So this is the presence call. Here's my reference to PubNub. I call presence, channel name, and a implementation of the presence callback. So just jumping into that. My presence callback in this particular application keeps track of everybody that, all the Chatterbox callbacks that want to listen for presence on that particular channel. It takes a reference to PubNub, and it maintains a global presence list as well. We have two success overrides. There's an older style success override that just gets a channel and a message, and then the newer style override, which is the channel, message, and a time token. I would definitely use this versus the first success callback. This will give you that time token, which can be very, very useful for you for displaying time and date information to a user, or just using it for history. Okay. The implementation of the callback is fairly simple. Again, I check to see if the message I'm getting is an instance of a JSON object. I store a reference to that message, or store a reference to that JSON object in message.json, log it out. I grab the action parameter from that message, the UUID. These are the two that are most important. And then in my case, I instantiate a user profile or declare a user profile. I set the action and time token on that. And then I check to see if it's been a join event. If it is a join event, I update my global presence list. If it's a state change, I assume that I have that, that profile in my global cache, so I grab it out and grab the most recent state and store that. in that user profile and put it back in the global presence list. If it's a leave or a timeout, then I remove them from the presence list. And for presence, this really is all there is to it. It's just a series of 4 different events. You want to have a handler for each one of those events, and you want to know which application needs to do on those given events. Okay. Presence needs to be a source of truth. Either you accept presence or you don't. When you're listening for presence events, they do lag somewhat behind what just occurred, and sometimes it's better to think of presence as what just happened, not what's happening right away. And you want to either accept that in your application, or you can use here now or where now, which we'll take a look at to retrieve a list of the active participants on a given channel. Okay. All right. So back over. All right. All right, there is also a state method that you can use to set state, and there are some examples in the code there for that. For getting state on any given channel, if you want to get the state of a user 123, for example, you could use the PubNub object.getState, give it a UUID and the channel name, and it will retrieve the state. Same schematics are as many of the other calls, which is just passing in a callback and retrieving that state information. Okay. You can set state. Setting state can be anything you want it to be. So in this particular case, I'm instantiating a new JSON object, putting in user profile data in that JSON object, and then I use the set state method to set that state for that given user on that given channel. Okay. Here now and where now, these are 2 calls that you can also use to retrieve user information on a given channel. Here now will give you a list of the users currently subscribed on a channel. Where now will take a UUID. If you knew a particular user, if you were looking for which channels I was subscribed to, for example, you could pass my user ID to where now, and that will give you a list of the channels that I'm actually subscribed to. So here now will give you a list of the users within a channel. Where now will tell you which channels a user is currently subscribed to. Okay. All right. And there are some examples in the code of where now and here now as well. Making the world persistent with storage and playback. So one of the challenges with real-time applications and folks that transition from one task to another on a mobile device, they're using one app 1 second and transitioning over to another, is your app will get pushed to the background and then eventually be pulled back to the foreground. Well, while your app is in the background, you may not want to subscribe and receive messages because that would burn up a battery. And when it gets pulled back in the foreground, you need some way to recreate the world as it should be for a given user. Storage and playback is a component that's offered by PubNub that will allow you to do that. Essentially, every time you publish a message within the PubNub infrastructure, if you tell it to store it in history, it will store that data in our data center and make it retrievable for you using time tokens and various filter parameters. So that's what making the world persistent consists of. It really boils down to just one method within the API called history. And as you may have guessed, history accepts a name of a channel, the number of messages you want to retrieve, and here I have 100, and whether or not to include a time token. And that's the true parameter right here. Okay, so in this particular case, I'm asking for the history, all the messages that have been published, the last 100 messages that have been published to the AWG Desk Global channel. And again, our friend callback is present. We implement success callback, and I'm implementing the older style one here, but I'm grabbing that data back and processing that data. Okay. There are some limitations on history. You can only grab history for one channel at a time. So if you're using multiple channels and you have to recreate the environment based on data across multiple channels, you need to retrieve history one channel at a time. It will only return to you the last 100, the maximum of the last 100 messages that have been published to that channel. So if you need to go further back, you'll use a time token to do that. Okay. And we'll get to that in just a second. You can include the time token or not. That's entirely up to you. And so just to give you a little bit more in-depth look at what's actually returned, the response payload that's sent back to your application is going to be an array of 3 different elements. The 0 element is a list of the messages that met your criteria. Element number 1, or the second element in the array, is the oldest time token associated with those messages. And element number 2 is the newest time token. So as I said prior, you're going to get the last 100 messages from history, and you may need to go further back than that. If you need to go further back than that, then you're going to want to use the newest time token or the oldest time token for that. And you can grab that from the payload being returned from the initial history call. Okay. And here's an example of that payload: a list of messages, oldest message time token, newest message time token. All right. Count, which is the second parameter here, limits the number of messages being returned. If you only want to get 10 messages, then just grab the last 10 messages. The maximum is going to be 100. Time tokens, you can use the start. There is a start and an end parameter for the history call. There's an override that accepts a start and an end parameter. But before you can use the start and end parameters, you're going to want to use the time tokens. And so in this particular case, I'm going to create a time token for 5 minutes ago. I can grab the most current date, grab the time, apply this formula to it, and that will give me a 17-digit time token that I can use to retrieve messages from history. Okay. All right. Start always returns messages older than the time token value. So in this particular case, we're going to use a history call with a long value of start, and it's going to return messages older than start. So if I say pass in this value here, which is the 142198, etc., as the parameter for the history call, it's going to return messages older to that, but not any message that was sent at that particular time. So if you want to get that message plus messages that are older, you want to increment your time token by 1 or 2, and then you would get that message as well. But it's only going to return the messages older than that time token. Okay. And always returns messages newer than the provided time token. I think the callback, okay, here's the callback, here's end. And you can pass an end, and it will return messages newer than that time token. Okay, same concept. You can use start and end together. You can use start and end together to filter messages or narrow the window on the messages returned from history. Start is exclusive, end is inclusive. Okay. You can also reverse the history, the order in which the history is returned. Okay. So when true returns the messages from the beginning of time versus the other way around, which would be from the end of time going backwards. All right. Include time token. I mentioned this earlier. You can include the time token in the messages that are being returned, and that may give you some ideas to when those messages were sent. Okay, usually a good idea. but it does change the structure of the results. What will happen is that the messages coming back will not only be the message, but it will include the time token for each one of those messages. Okay. All right, so going back over the code here. Find my history call there. So for history, there is a method within the service. It's Chatterbox client, and I just grab a time token. That's actually incorrect. Need that 0. Do a get PubNub. I use the history method. I pass in the name of the channel. I go 5 minutes back, just as in the slides. I pass in a -1 for start. Or I'm sorry, -1 for end, meaning no end. Pass in 50 here for the number of messages I want to retrieve. I do want to include the time token, and then I have my callback here. And then on my callback, I would just do my processing. In my case, for this particular app, there's not a whole lot of reason to use history for the sample application, but more likely than not, in any kind of production app that you have, you're going to want to deal with intermittent connection problems, and history is the way to do that. So if you're disconnected, you reconnect, go to history, get the messages since the last connection, and show them to the user. Okay, same callback structure. Everything on the SDK uses this instance of callback, very straightforward, and it passes in a generic object. That object is always going to be, for history, it's going to be an array, a JSON array, and then you can start processing the array as you see fit. Okay. All right. See if we have any questions here. It says, all right, so we have one question. How long and how much message will be stored in history? So history is configurable. If you sign up for history with PubNub, you can configure the messages to be stored for 24 hours or indefinitely. It's entirely account specific. So as you create your subscribe key, you can go in and configure those messages to stay around for as long as you need them to stay around. Okay. All right. Push notifications. All right. So PubNub is a gateway to send push notifications. You need to have push notifications enabled on your account first, and that can be done in the PubNub portal. You need to obtain a sender ID and an API key from Google. So this is a GCM or a Google specific step in receiving push notifications. And then once you have the API key from Google, you can configure the API key in the PubNub portal. Once you have those prerequisites met, then you can start to implement the code required to receive push notifications. Just to break down how push notifications are actually implemented, you have an application that wants to send push notifications. This could be a server-side app or another mobile app or a desktop application, whatever the case may be. But you will want to send those messages to a PubNub channel with a very specific payload. And when you have a very specific payload or a GCM payload embedded in a message going to the PubNub channel, if there are devices registered on that channel to receive push notifications, PubNub will then send that or forward that push notification to the service provider. So it would either be GCM or APNS or MPNS, whatever the case may be. For Android, it would be GCM. And then GCM, Google, will actually deliver that push to your application. So once you've sent the message from the app with the correct payload and everything else is configured, PubNub simply forwards that on to GCM. GCM then delivers that to your app, which means there are some things on your app that you'll want to have configured, such as a broadcast listener, or a broadcast receiver, so that you can receive push notifications. Okay. So just to run through that process, the application sends the sender ID to Google. Google gives the application a device ID. This is sender ID is actually the product ID on the Google developer site. The application registers a device ID and a channel with PubNub. So if I had my phone, I would have a device ID. It's a very long cryptic number, but let's say 1234. I would say device 1234 wants to listen on the AWG global channel to receive push notifications. The application publishes messages with the proper payload, with a GCM payload. If you look at the developer site, there are examples of GCM payloads there. It's essentially a JSON packet with an attribute in it called GCM, and within that GCM packet, you would have a payload attribute or a data attribute. PubNub, when PubNub encounters that payload, it will forward that message to GCM with the device ID. At that point, it's up to Google to send that push notification along. And if you read the Google documentation, sometimes those aren't guaranteed and the timelines are not guaranteed. But typically, this is done within a matter of a fraction of a second. You'll start to see messages received. All right. Another way to look at it, the phone registers with PubNub, or the phone sends a push through PubNub that goes to Google. Google then delivers that message. All right. So just prerequisites again, and we're covering this a couple times, but push is something that requires a lot of interactivity across organizational boundaries, so from PubNub to GCM as well as with your application. So it's important to have everything configured correctly. You'll need to have push notifications enabled on your account. You need to get a sender ID and an API key from Google. All right, and then you can start implementing the code. From a permission side, application level specific permissions need to be granted, and that would be in your manifest file. I'll just take you over to that. So in Android Studio, if you're looking at the Android view, the top element will be manifest, and that's your Android manifest file. You need to have very specific permissions enabled in order to use push notifications. One of those is internet and Wi-Fi. You would need that just to connect to PubNub, but also for push, and then wake lock. And if you have wake lock, that will allow the device to wake up when a push is received, and then you also want to have a receive permission. Okay. This is actually slightly different. Put that there. These two permissions will allow you to receive push notifications. Okay. The next thing you're going to want to do is ensure you have an actual receiver. And you do that with the GCM receive intent filter and a GCM broadcast receiver. You'll need to have that implemented in order to receive push notifications, because as I said, we send the push to Google. Google then sends the push to your device. So after we send it to Google, we're actually out of play at that point. It's no longer in PubNub's control. Google will then return and send the message back to you. During the time that you get a push notification, you'll also receive regular PubSub notifications. So that's something to be aware of. Just because you have a push payload doesn't mean that you're not also going to get the PubSub. Okay. All right. Back over there. So again, keep your GCM broadcast receiver configured in your manifest file. That will allow you to receive push notifications. And prior to this webinar being put together, just prior to it, Android started to change, or Google started to change the way you interact with the Google Cloud messaging. They actually have a step-by-step tutorial on the developer site, developer.google.com, on how to implement Google Cloud messaging, and I believe it actually has buttons that allow you to download all the files now. So I would highly recommend that you use that and integrate that into your app. It's using all the latest, greatest APIs and is completely done for you. So it's almost a canned solution at this point. Debugging a push notification, because we actually send that push notification off to Google, and then we have to rely on Google to deliver the push notification, it can get somewhat gray on diagnosing push issues. We do offer the ability to debug push notifications on the PubNub side, and you would do that by using our developer console and subscribing to a channel called PN-Debug, or to the channel name plus PN-Debug. And some examples of that is here. If you had a channel called Test, subscribe to test-PN-Debug. And as you send push notifications across that channel, just as you would publish any other message, you'll get some diagnostic output for the push notification, and it'll essentially show you or tell you how many devices it found on a given channel and whether or not a push message was sent, meaning we made a connection with Google and had no issue. Okay, so definitely use PN-Debug to debug push notifications. In order to send a push notification, it's very similar to a publish. There's no difference between calling publish to send a regular PubSub message versus calling publish to send a push notification. But before you do that, you want to enable push on a given channel, and there's a method call to do that. We have that in code here, so jump out. Here, find enable. So in my particular case, in the sample application for the Chatterbox client, which is used by the service, whenever you disconnect from the service, meaning you've killed the application, I want to go out and register and ensure I enable push notifications. And I do that here. So I grab an instance of Google Cloud Messaging. I register my project ID, which is also the sender ID in the slide. So sender ID. Add those there. I register that, I grab that registration ID back out, I just do some logging, and then I use PubNub and I say enable push notifications on a given channel. So there's an array of channels that I'm subscribed to. Whenever I close my app, all the channels that I'm currently subscribed to, or the rooms that I'm in, I want to enable push notifications for those, and I pass that registration ID. From a PubNub perspective, as long as you have this done, your payload contains a GCM push, which would look very, very similar to this. As long as your payload looks similar to this, the important part is that you have a GCM attribute, and the Google constraint is that you also have a data attribute. As long as you have that, whatever is within this data attribute will be sent along to Google and become part of your push. Now, there are other attributes that you can add in that are Google specific, and I would refer you to the Google developer site in order to determine what those are. But the important thing is that you have a GCM. So in PubNub land, if you were to do a chat message, and you want it to also send a push message at the same time. So if you want to do a chat message and then also send a push message at the same time, you would have your content set up similar to this, where CM is some JSON payload that you want to send. It could be anything that you want. And then you also have a GCM attribute at the same level as your content, and it has a data attribute within it. That would send a PubSub message with message content plus a push notification, okay, from a publish side. Now that doesn't receive the message, that just sends the message. The broadcast receiver is the one that will actually send the message or receive the message, and that is more Google specific, and it's just a matter of grabbing data out of a bundle using that receiver, okay? But the very important part is make sure your payload is correct and you've enabled push notifications on the channels that you're interested in receiving push notifications on. Okay, and that will enable you to receive push notifications. Okay, all right. Again, just jump back over. Make sure you have that GCM attribute, and that's what will tell PubNub that it is actually a push notification. But prior to doing that, make sure you enable your push notifications on a given channel. We have some overrides of that here. Essentially, it takes channel names, a GCM registration ID, and a callback, or you can do more fire forget, which would be an array of channels with just the registration ID, or you can pass in an array of channels with the callback. I would always recommend using the callback because then you get some indication that the push notifications have been enabled on that given channel, but you don't have to do that. Okay. Okay. All right, so we went through doing initialize, subscribe, so setting up the development environment, initialize and subscribe, publish, PubSub, and push notifications, and history and presence. And we have some additional resources out there available to you. The knowledge base is available at pubnub.com/knowledge base. We have a developer community that is also available. You can ask questions on the developer community. Of course, we have our support, which is can be accessed either at support.pubnub.com or support@pubnub.com. And of course, we have docs, demos, and SDKs available to you at pubnub.com/developers. I know on the 28th, we also have an iOS webinar coming similar to Android for developing apps with iOS application, and that will actually cover our version 4 of the iOS SDK. So if you're interested in attending that webinar, please do register. Other than that, thank you very much for coming, and I'm going to open it up for question and answer and see if anybody has any questions. Okay. Oh, we do have one here. So we have can a server-side. So we have one question from Sandeep. Can server-side logic decide that it wants to publish a message, then create the channel and add the users to the channel? Not server-side. There are ways to implement that, Sandeep. If you want to send a support ticket in, we can definitely walk you through how you might want to approach that. It might be a little bit more chatty than you could imagine, but it's definitely possible to do. Server-side can determine who to send a message to based on application-specific criteria, and then you can use some auxiliary channels behind the scenes to send control messages to various users to tell them to subscribe to a channel. So that's one way to do it. Okay. All right. We have another question. What is the minimum Android SDK requirement? Is there one for using PubNub? Not for using PubNub. PubNub is very plain Jane Java, and behind the scenes it's using a lot of REST APIs, HTTP calls. So I believe that'll actually work going all the way back quite a ways on the Android SDK. For this particular one, I believe I used. Let me check that for you. Let me see. Tell you, I believe I used the version 22 of the Android SDK, or version 22 of the runtime. And you can go all the way back to like 18. I think I tried it all the way back to 18. No specific requirements though. And Craig has chimed in. He thinks it goes all the way back to 4.2 of Android. So in this particular case, I'm using API 22. But I've also used 21, and I think I had 18 in there at one time and had no issues. So good question, Prakash. How do you under-register a user from sending a push notification? Just as there's an enable call, there's a disable call, and you would usually want to do that when an application starts up. It's a very good point. We should probably add that to the slides. Just disable the push notifications on the given channels that you were enabled for. And it's not a question of knowing the channels. You can send any list of channels down. If they're registered, it will unregister them. You can re-register for channels with the enable call. If they're already registered, it'll just overwrite their previous registration. So, okay. Okay, well, thank you very much. Unless we have any additional questions, I think we're in good shape. Thanks for attending the webinar. Please do stick around after the webinar closes. There is a survey and you can register to receive or to win an Ozo bot. Thank you very much. Have a great day.